Hello, welcome to this webinar on the use of Hydro International's design tools. Today's webinar will be hosted by me, Carl Hall. I'm one of Hydro's regional technical managers, and my colleague Steve Waters, who's our technical proposals expert. Now, I will start with a quick overview of what we provide at Hydro International for stormwater management, and in particular our solutions for controlling flow and controlling pollutant load in stormwater runoff. It's not exhaustive, but it covers those products for which we can now provide online resources to designers who'd like to develop their own designs using these particular technologies. So we'll look at how those technologies work and how we can design them to operate at their best using the design tools. It's worth bearing in mind that suboptimal design can lead to inefficient operation of the asset on site and, of course, increased costs for the operator or owner of the asset. I know some of you will already have seen some of this upfront content, but please bear with us as we move on to the modelling part. We'll have a look at flow controls first, followed by the Hydrobrake design tool, and then we'll look at stormwater treatment options, followed by the treatment design tool. We cover all of the bases with 6 core application areas, from large-scale flood alleviation schemes, flow control and attenuation for general development, hydrometry from site-specific up to catchment-wide scale, and a range of specialised equipment for clean and wastewater treatment. First up is flow controls. We supply flow controls to cater from the very biggest to the very smallest applications, so we'll have a brief look at those first. We provide subsystems for residential, highways, private commercial and public developments, and we also provide vortex flow controls for sewer networks across the UK, many of which are approved and adopted by water companies. We also design flow controls for blue roof applications, and for those schemes where the greenfield runoff condition needs to be replicated, we can accommodate that requirement by providing multiple Hydrobrake flow controls, each set to meet the specific control points required. The risk of flooding to an area can be significantly reduced, though, if we moderate the volumes of water flowing down the catchment, and this is typically achieved by throttling the flow to a reduced rate and temporarily detaining the water volume upstream. Precise and effective modelling is vital for us to get the best result, so we might finish up with a less effective and certainly more expensive attenuation arrangement. The second part of this webinar will focus on how we can achieve that. Hydrobrake optimum flow controls are guaranteed to give the best performance from a vortex flow control as a result of huge amounts of R&D investment. For this current iteration, we invested 600 days of lab tests that followed from 10 years of design development and computational fluid dynamics modelling. The design tools that we look at today incorporate all of this design development. We can be quite sophisticated in designing flow controls to meet a specific need, and we can, for instance, engineer the control to kick in at an early stage to reduce downstream flooding to the fullest extent, or at the other end of the scale, engineer for maximum hydraulic efficiency to reduce the upstream and expensive attenuation tanks, or indeed we can tailor this response to any point between these extremes, as the orange lines show. The design tool allows you to explore these options. We know that conditions in a catchment might change over time, and where that has been the case previously, we'd need to change all the flow controls to allow for changes in flow. Today we can provide flow controls that have the facility for future adjustment, so we won't have the expense and inconvenience of changing the controls at that future time. We can future-proof the flow controls using adjustable or interchangeable inlets. There are a number of methods for designing flow controls, including microdrainage, that's probably the most used, but also WINDES, causeway flow, and InfoWorks. If you use WINDES, you can import outputs from the Hydrobrake design tool into it. Causeway now has inbuilt Hydrobrake information, But if you use InfoWorks, we'd need to give you a compatible data file. So we'll now look at a case study for hydro breaks. This is a large residential development where multiple hydro breaks were used. Flow controls shouldn't be seen, though, as a standalone entity. They often form part of a more sophisticated drainage arrangement, such as this large housing scheme. Here, the flow controls form an integral part of a very sustainable suite of provisions. There were 1,900 homes built between 1999 and 2008, were part of a water and new developments, or WAND, project. WAND, in fact, was a collaboration of several UK universities together with the Centre for Ecology and Hydrology at HR Wallingford, and looked at the holistic management of the water cycle as delivered at the local level in new developments. And finally, before we look at the design tool, these are the basic options you can choose from. If we select HE and the design tool, this will minimize our upstream storage. So if we want to get the maximum amount of water off the side before the flow control throttles the flow to the required discharge consent, this reduces the size and cost of the upstream attenuation volume. It's the most popular choice as it's the most hydraulically effective. If we select CL in the model, this will minimize blockage risk. So if we want the largest opening in the hydro break, that selection will provide that. If we select FP in the model, that stands for future proof, and that's where we can allow some adjustment of future flows in case of changes in the network in future. For instance, if new phases are going to be added into an existing network. And finally, if we select CU, this gives us what we call linear discharge. If we want the unit to kick in very early to reduce the volumes of water passing downstream, if we know there's a heightened risk of flooding downstream. Right, I'll hand you over to Steve now, who's going to look at the modelling tool itself.
Well, good afternoon, everybody. What we're doing is taking you through the Hydro online design tool for the Hydro break Optimum in this sense. So I'll just try this over here. So the URL, as on the last slide, is hydro-int.design. So when you first reach the page, you will need to either register an account or log in. For purposes of this, I will be logging in with an external account to show the tool as it would be for yourselves as external users. So this is the homepage, the dashboard. As you can see, we've got the Hydro break Optimum vortex flow control design tool, and we've also got downstream defender first defense separator tools, which I'll be showing in the second half. Just very quickly, when you've got your free login, one of your options in the top right hand corner is the settings. Very important to double check these and make sure you've got the right language, English United Kingdom rather than English United States. Reason for this is that our American division also has a design tool, and the products, whilst they look similar, in some circumstances are different. And so in order to make sure that you've got the right unit size for you, just make sure that you've got English United Kingdom, the units are metric rather than imperial, and your region is Europe rather than North America. So once you've got that and saved it, you should be good to go. So if we jump into the Hydro Optimum design tool, so as you can see on here, on the left hand side, we have the first two boxes are reference number and site name. So the reference number and site name appear on all the outputs that will be generated from the tool. So we always suggest that for reference number, you put in if you've got an internal project number, etc., and obviously the site name. Very good to remember this. Put it on there, get it on the outputs, and also, as I'll show you later on, when you save this as a project, you can also have that to help you differentiate between different controls and different vortex separators and different manholes on the same site. So if we go down here, and I will call it flow control 1, I'll call it test site 2. You then got onto the primary design points, which we need the design head in meters and the design flow loops per second. As you will see, these two fields and a few of the fields below have a red asterisk next to them. Anything with a red asterisk needs to be filled in order for our design tool to work. So in this case, I will put in one of the favoured historical heads and flows. So 1 meter of design head and 5 liters per second design flow rate. We then move on to the objectives. These are some of the objectives that Carl alluded to in his earlier slide. We're going to keep this HE, which it defaults to minimise the upstream storage. We've then also got the flush flow point as well. The flush flow point is not required in order to output a design. If you leave it blank, the Hydro Optimum will attempt to set the flush flow point as close as possible to the design flow. Our second design that I would do after this one, I'll put in a flush flow so you can see the slight difference in the curve. We've then got a water type, which is defaulted to surface water only and sub available as yes. This is a simple yes/no choice. You then also got the mounting style. You've got a flat mounting plate, a curved mounting plate, which helps you save time and labour costs on site. You don't need to create a head wall for the unit. You can just mount it directly to the chamber wall over the outlet pipe. You then also got the option to have an adjustable inlet or not. If you select adjustable inlet, the unit will design as normal, but it will have an adjustable inlet and its code will be SFP, which is future-proof. So seen a couple of questions about design head. I'll just zoom back to that. The design head is based on the maximum depth of water in the system. So if you were to have storage, say 0.66 meters high, for instance, and the hydro brake was at the same invert level as the bottom of that tank, you would then say that your design head was 0.66 meters. Essentially, you go from the invert level of the hydro brake, where it's mounted on the outlet of the chamber, to the top water level anticipated in the system. Now, this might be in storage blocks, storage pipes. You might be going a culvert, top water level, in a lake, detention basin, etc. So that is essentially how a design head is calculated. So it's a vertical distance from the top water level down to the invert level where the hydro brake is. So in this case, we've got 1 meter design head, 5 liters per second flow rate. We'll keep the objective as HE. We won't put a flush flow in, and we'll keep all these as their default. Now, our design tool does do S-type optimums and C-type optimums, and the way the design tool chooses whether to use an S or a C-type optimum is through a combination of these site options. So for instance, if you change surface water only to combined surface and foul water, it would then default to a C optimum rather than S optimum. There are also built-in limits in the design tool for flow and head, which are based around our BBA certificates. So up to 250 litres per second stormwater flow. If you choose that, it will give you an S-type optimum. If you go above that flow up to 550, it will give you the option of a C-type. Now, myself and the other hydro internal engineers are able to see this design tool from an internal perspective, and we have slightly more rights in the tool, and we are able to override this. So if you do come across a situation where you do need an S-type and the tool is giving out a C-type, or it is saying that it's not possible, then please contact us via the website, our main number, emails, etc., and we will be able to answer any questions you've got. I'll show you the support section later on as well, which details exactly how you can contact us. So, leaving the mounting style and the adjustable inlets as they are, if I click design, we then should get, after a few seconds, an SHE 0105. Now, what this full code means, so it's an S-type optimum, it's hydraulically efficient, so that's the optimization that we chose, the objective. The 0105 means that the outlet diameter of the hydro brake is 105 millimeters. The 5000 refers to the design flow rate of 5 litres per second. The 1000 refers to the 1 meter design head, and then the second 5000 refers to the attempted flush flow point. Now, if you don't define a flush flow, the code will always come out with the design flow twice, so the same number. As I'll show you in a second, when we design the second unit, if you specify a flush flow point in litres per second, the second flow rate set of numbers will change. So as you can see from this, we have a unit that has a primary design point of 5 litres per second at 1 meter head. It is actually able to reach 4.98 litres per second at the flush flow point, which means that it's passing as much flow as possible below the limit at a much lower head initially, which removes a lot of the storage requirement. It gets rid of that volume in the first flush of the storm. It then goes back to its kick flow point. This is the point where the vortex within the unit is completely stabilized, and it then starts acting more linearly before going out to the design point. So as well as being able to see what the hydraulic characteristic of the unit is, you get the mean flow of the head range, and you then get a image giving you the key dimensions. So again, we have the internal clearance of the worst case of the inlet and the outlet diameter, the unit depth, width and span, as well as the material thickness. We are able within the tool to design units that will automatically switch between 3, 5 and 8 millimeter 304L stainless steel to deal with being large units, and having more heads, more pressure on the units means they have to be thicker to be able to stay under a certain deflection to obviously keep the BBA certificate approval. Also, very importantly, you then get a minimum outlet pipe diameter. So there is a logic behind it. We don't tend to go within about 12 to 15 millimeters of an outlet pipe size. So if this was a 145 rather than a 105, we would not say to fit on a 150, purely because the unit itself will be so close in outlet diameter to the pipe diameter that it might not function effectively. There might be an issue with back pressure and the unit not acting as we intend. You can also have a suggested manhole diameter, and then obviously minimum sump depths and block widths. The block width and height and sump width and depth are used for if you're going to be making your own chamber on site rather than buying one from one of our our suppliers. So what we'll do is, once we've got this sized up, is the two options at the top. You have the save button and an export button. And I'll quickly also say that when you've designed any of the 3 products in this design tool, you then have a hyperlink to the product page. So if you would like to go and see general design drawings in CAD format and BBA certificate, etc., general overall product literature will be on the product page. So if you click on that, it will open a new tab and it will take you to the relevant product page on the Hydro International website. So we've got these 2 buttons. You've got save and export. So if you save, you then have the option to add the design of this Hydro Optimum to a current project that you yourself has created. So all these designs and projects are linked to your login. So you won't be able to see projects that you yourself have made. So in this case, I have a few test projects. So in this case, I'm going to create a new project. As you can see, as with the red asterisk, you've got the name of the site. You can have reference number for this if you want to. So HB1. And then all you need is the city. So we're based in Clevedon, so I'll put in Clevedon. Hit save, and essentially what that will show you is it will appear in your list of projects in the top left. But what I'll do first is I'll go to the projects tab. So in this case, on my login as an external user, I have these demo sites that I have designed myself and saved. You don't need to save in order to export the tools. If you don't wish to save it and you just want to get in and have an output, that's fine. You can just export, which I'll show you in a second. But if you have particularly large projects with multiple flow controls and multiple separators on there, then it does make a lot of sense to be able to track them by keeping them in the design, the project's part of the design tool. So in this case, if I click on test site Clevedon, I now have my flow control 1 reference in there. Now, what I can do with this is I can delete it if I no longer need it. I can edit it. I can export the documents from this page rather than going back in and redesigning it from the main page, and I can rerun the design as well. So if I export the documents, the options I've got the hydraulic characteristics, the PDF design drawing, the GA drawing. We then have micro drainage and causeway flow data, along with the Windows 11 data. These are for older versions of micro drainage and causeway flow that do not have the Hydro Optimum natively built into them. And then for other packages, we just have a generic CSV file. So in that case, you would tick yes or no on the ones you want, and then when you download them, it turns away for a few seconds, and it then allows you to view them in either, in this case, PDF or CSV files. So I'll run for a second. So what we'll do is, while that's running in the background, it normally does take a few seconds, but if there's a slight bottleneck in the internet connection, it can take a little bit longer. But what we'll do is we'll go back into the Hydro Optimum page. Oh, here we go, it's just opened up now. So when you've got more than one output, it will put them into a zip file and it'll be able to download them for you. So the outputs from this tool are a GA drawing of the unit with all the same information for building a chamber. Seen a couple of comments about the minimum chamber size. Definitely is driven by the minimum pipe size as well. When we do stuff with CPM, they will always ask us what the outlet pipe diameter is of the chamber that they're doing, but that needs to be tied in closely with the Hydro Optimum because it might need a backplate, it might preclude certain mounting options if it's particularly big. For smaller sites though, when you're running all 150s or all 300s, you're probably going to be putting in 1200 and 1500 chambers, but the hydro rate might need an 1800 chamber, so it is to be used in conjunction as a minimum requirement, size requirement, along with other requirements on site, such as the minimum pipe size, the number of pipes, access, etc. So you get a GA drawing of the unit, and you do also get the hydraulic output, again putting in the flush flow, the kick flow. A couple of comments, people asking about what the flush flow and the kick flow are. The flush flow point, essentially a hydro brake acts as an orifice initially of a certain size, the physical size, up until just before the flush flow point. So it will, this flat portion at the bottom is where the water is passing through the unit. The unit hasn't initiated a vortex internally yet. When it gets up to the flush flow point, this is when the vortex starts initiating. The fact that that vortex has started means that water isn't able to pass through as quickly. This is what we call the kickback portion of the curve. This is where you're getting the water being held back. Once it then stabilizes a vortex and you have another set orifice size, you essentially have the same physical orifice size in terms of the outlet on the back of the unit, but you do have a vortex in the middle of the outlet, therefore the water can only escape around the side. So this lower section is pre-initiation and this upper section is post-initiation, and the 2 points that define the start and the end of the initiation phase are the flush flow point and the kick flow point, essentially. So these are two outputs we've got. So what I'll do very quickly is I will run another design with the same primary design point of 5 liters per second at 1 meter head, but I will put in a flush flow point so you can see the slight difference in the outputs. So design head of 1, design flow of 5 liters per second, HE objective, but a flush flow point of 3 liters per second. All the other options will remain the same. Here we go. So as you can see, it's now a 91 mil outlet. It has been changed from SHE to SFF. FF standing for flush flow because we have defined the flush flow point. Also, the last 4 digits have changed from 5,000, the primary design flow, to 3,000, 3 liters per second. One of the reasons, or one of many reasons we have for the flush flow point being defined is that you can balance flows if you have a cascading system. So if your one unit is too efficient, it's letting too much water through and it's affecting downstream storage and downstream flow controls, you can pull the flush flow point back. Also very useful in complex control setups where you have to hit multiple design head and design flow points. You can, in a reasonable range of circumstances, design a SFF on one design point for like a 1 in 30th flow, for example, and then the 1 in 1 year design point can potentially be hit by pulling the flush flow back to a certain flow rate. So that's the reason for using the flush flow in this case, but there are also other objectives, as mentioned before. So we have a future proof, which is adjustable, and then a CU, for the smallest possible unit for linear discharge. So again, we can save this unit. We'll save it to the same project, the test site Clevedon. And then once that's saved, we can go back into our projects and we should be able to see that. Into the projects, and once it has saved, well, it should show. There we go. Takes a few seconds to update. It now shows that we've got 2 hydrohelicopter flow controls, FC1, FC2. These again are able to be deleted, edited, rerun as you see fit. So what you can also do once you've got a design, either purely hydro brakes, purely downstream defenders and first defenses, or a mixture of the two, is you can hit the "I'd like you to review my design" button, and that will then send an email to the internal team at Hydro International, and they'll be able to get in contact with you to go over whether your design needs tweaking. We can then also provide further design advice. For instance, if the unit that you're requesting falls outside the design parameters of the external tool, we can also provide pricing advice as well, because the external version of the tool does not show the prices of any of the units. And so with that, can I hand over back to Carl? Actually, before I do, very quickly, for those who asked about the design head, very simple image here showing what the design head is. So we have the design head going from the invert of the hydro brake up to the top water design level. There will be situations where you may have downstream surcharge, either permanently or temporarily. In that case, the unit can act under what we call a differential head. So the difference between the upstream and downstream water levels. If there is differential heads or there's a known risk of surcharge, then please contact us and we will be able to help you in designing the right unit, either based on a differential head or not. So, and I'll hand over to Carl quickly for the hydro storm drain.
Onto our treatment products, our storm drain series. We are seeing more and more requirements from planners and other stakeholders these days to remove pollutants from stormwater runoff. Sediments entrained in the runoff will readily transport themselves downstream to possibly sensitive areas, so simple and effective removal techniques are very desirable, because if we remove the sediments and the adhered pollutants, we're already a good way towards a solution. So we'll have a quick look at some options. And we've now built design tools for these two, which not only help you to get a quicker and more reliable result, but when we align the design regime to the simple index approach, which we'll look at later, we can provide design solutions that the planners can understand and approve. This is our current range of pollution removal technology. Today we'll just look at the vortex separators because they're currently featured in our new design tool. For a worst case scenario though, we might need to remove just about a full range of pollutants in the flow. So a complete treatment drain would comprise screening for the gross solids, then removal of separable solids by vortex separators down to around the 100 micron level, and finally removal of diffuse pollutants by filtration. Today again we'll just look at vortex separators, and bear in mind that petrol interceptors need to be part of this arrangement in most cases. Vortex separators, though, provide an effective means of detaining a wide range of contaminants, from debris to floating hydrocarbons, sediments, and down to the smaller particulates. Importantly, vortex separators will absolutely not allow the re-entrainment of the captured pollutant load, even under high flow conditions. So they're much more effective than simple sill traps. But we do need to make sure the design is robust. The treatment tool that follows will ensure that appropriate design criteria are applied. And pollution control should be applied in cognizance of the specifics of the site. No two sites are alike, and the sensitivity of downstream receiving waters is also going to differ. This example shows that a range of complementary measures have been allowed for, including engineered and natural mechanisms, which jointly ensure that the water flowing back into the river is as clean as is possible. Engineered pollution removal is particularly usable where high flows need to be dealt with, but where limited zones are available to effect a solution. Vortex separators have been successfully used on many highways projects, and this is a typical scenario. So I'll hand you back to Steve and we'll have a look at the treatment design tool.
Thanks, Charles. So as a refresher before that, I'm sure you're all intimately aware of the ISO 14688-1 soil classification table. It's great bedtime reading if you haven't done it. And it essentially puts proper classifications on sands, silts and clays. So when we at Hydro and others speak about what a sand or a silt or a clay is, we try and fit in with the soil classifications rather than just say, oh, that is just some grit, or that, you know, as a sort of colloquialism, and we're not quite sure what it means. So also got a table on the right hand side showing the D50 micron size for solids, grits, fine sand, and the WRC monitoring that was between 2003 and 2007, the first monitoring was. What we've then got is our assessing treatment requirements, and essentially this is the SimpliNets approach from Series C753, where you need to assign a suitable hazard pollution indices for whatever you're proposing to put on your site. Once you've got those hazard pollution indices for TSS, metals and hydrocarbons, you then need to make sure that your surge treatment train has a total pollution mitigation index that is the same as, so equals or exceeds, the pollution hazard index, and that's for each contaminant type. So not just one of them, but all three: TSS, metals, and hydrocarbons. You can see on the bottom right there is a list of typical soft SUS components, so filter drain, swales, detention bases, etc., and their mitigation indices. And to add to that, hopefully for people to consider and take away from this, we have the mitigation indices for the 4 hydro treatment products in our storm drain treatment series. So the upflow filter, the biofilter, which we're not covering today, but then of course the first defense and the downstream defender vortex separators. So what we'll now do is we'll jump into the sizing tool for this. So again, you go back to your main page. We've hopefully covered the Hydro-Rec Optimum in a reasonable amount of detail. Same dashboard, you've got the downstream defender and the first defense. So what we will do is we'll go into the downstream defender and we will design one. So again, we have the project reference number and the site name. So again, I'll do this for downstream defender reference for this one, and it'll be test site 2 for this one. Now, what we have on the left-hand side, below the test site, below the site name and the reference number, are the sediment types. Now, what I'll do is I will hover over the sediment types, give you all a few seconds to read what the fine and coarse flow rates are based on. These are all based on third-party testing, verified third-party testing. We can provide information to back up our removal efficiency if required. So in this case, we will stick with the TFR fine, so the treatment flow rate for fine particles, and we then have to fill in, as well as choose a type of treatment flow rate, either fine or coarse. We then have the design flow rate and the peak flow rate. Now, the design flow rate is water quality flow rate, usually a 1 in 1 15-minute storm event. So this is the flow rate where treating this will provide, should remove vast majority of all of your initial pollutants, because this is essentially the first flush. Now, both our downstream defender and first defense, each size, as the design data sheet shows and the outputs from this tool show, have a design flow rate, after which point they bypass to protect what they've already removed, to prevent re-entrainment. And then they also have a peak flow rate, which is the worst case flow that they're going to be expecting to see. And this is generally the sort of the hydraulic capacity of the unit. So in this case, we're going to put in 15 litres a second for the design flow rate, and then 60 litres a second for the peak flow rate. We've also got below the design button, if you already know and you've sized these before, there is a I already know the unit size button, which enables you to jump straight into picking the unit size rather than having to go through this. If you've already done it before, or you are going to the design tool and you just want an output for a client and it's already been designed by somebody else, you can jump straight to the unit size rather than having to find out what the design flow rate and the peak flow rate may have been to design the unit. So if we hit the design button and wait a few seconds, we then get the downstream defender as our output. Again, there's a link to the product page where there are generic CAD drawings on the product page. This is the same for the first defense, downstream defender, and the Hydro-Rec Optimum. There are generic details in PDF and in AutoCAD, both 2013 and 2000, I think, versions to enable you to put them into your tender documents. We've then got a unit reference. In this case, this is a 1.2 meter internal diameter unit, which as standard comes with 300 DN inlet and outlet pipe sizes. If there are other pipe sizes existing or designed in on site, you are able to use them on the site. However, the unit itself must accept, in this case, this diameter must accept 300mm in and out pipe sizes, and then you have to leave a few meters either side of the correct pipe size before stepping up and stepping down to the site pipe work. What we've also got in here, as well as the pipe sizes and the diameter, is the minimum ore storage capacity for a standard unit. Units can be made deeper to increase their sediment storage capacity, which is listed below here. So this is a standard unit, so excluding the cover and frame, that's what we mean when we say cover, is 2.83 meters. Now, this image shows the unit in a reinforced concrete chamber. We do also provide the 1.2 and 1.8 units in structural spiral wound twin wall plastic chambers, and then we provide all four sizes, 1.2, 1.8, 2.55 and 3 meter diameter chambers in concrete, reinforced concrete, and non-structural single wall plastic. The benefits of the single wall plastic being that whilst it isn't structural, it is a lot lighter. On site, it does need to be backfilled with concrete to provide a structural surround. But the benefits of having a very light unit that you can put on site without necessarily needing a large crane can outweigh the extra work on site required to make it structural. So in this case, 1.2 meter unit, all the information above in a nice little table. You've also then got the performance hydraulics of the unit. So it gives you the maximum treatment flow rate. So in this case, 38 litres per second. So the 15 litres per second design flow rate is well below that. Hydraulic capacity flow rate is 120. So again, the 60 litres per second we put in is well below that. The typical operating head loss at the treatment flow rate is 150, and the maximum head loss the unit will ever see is 500. So look at some of the questions in terms of maintaining the unit. Very good question. The internals are made of high density polyethylene. They can be jet washed to clean them. Generally speaking, when the unit needs to be emptied, there is a hole down the center shaft which enables the sump at the bottom of the unit to be accessed by a vac truck to remove the sediment, and then the floatable storage around the outside of the top of the unit again can be accessed from the surface to be have floatables and all removed by a vac truck. So again, once you've got this unit designed, we have then the same options of saving or exporting. So if we save it, we'll save it to the Clevedon test site again. And then we'll go ahead and export the units. Now in this case, you have a design summary showing what unit size it is and its removal rates, and then the PDF design drawing. So I will download that, and while that is downloading, I will jump to the projects page again. Hopefully in a few seconds it will have updated itself. Fantastic. So again, we have the two hydrocoupling flow controls that we previously specified, along with this downstream defender. And again, you can delete, edit, export the documents, or rerun the design. So what we'll do is, after a few more seconds, hopefully the download will have kicked in. If not, what we'll do is we will go to the front page again, and we will go to downstream defender, but we will click the I already know the unit size button. And again, you've still got the option of the reference number and the site name, but you do have the option to just simply select the unit size to get that what you want. So downstream defender has downloaded now. So the two options that you will get is a GA drawing. Now this has been done with some filled in, so the weights and the heights of a standard unit and the treatment flow rate following course. There is on the bottom left hand side a table that allows you for specific jobs to put in the cover level and the inlet and outlet levels of the pipes, what the materials are and what the diameters are. Again, it can accept, it can be put into a system that has larger or smaller pipes. However, the unit itself is designed to only accept, in this case, 300. So each of the 4 sizes of unit have a standard pipe size. So there are 300, 450, 600 and 750. But again, if you've got any issues with the pipe size, either existing or proposed on site with a Downstream Defender or a First Defence, or indeed a Hydro Optimum, if it's telling you a minimum outlet pipe size that is above what you're proposing or what you have on site, then please contact the Hydro internal team and we'll be able to help you out and give you some design rules to follow for those units. So this is the GA drawing for the Downstream Defender. We've then also got the technical detail which feeds from the inputs that you've put in. So in this case, you have a essential design summary, very basic specification document, which shows what you've put in as your design flow rate and peak flow rate, and then the unit reference and the general size of the maximum head loss. So view this as the hydraulic summary, and the drawing is the GA drawing, the actual unit sizes. So what we'll do again is we will jump straight into the First Defence dashboard. Once again, the reference number and site name are there. So we'll call this FD1, test site 2. Now in this case, sediment type, it is a simpler set of internals of First Defence, and so there is only a TFR course rating for this. But again, we do have the design flow rate and the peak flow rate. So if we put in 15 litres per second again, but we'll go up to the 120 for the peak flow rate to get a different unit size. We hit design. Again, there is a link so you can jump in if you know the unit size already. So we'll press design and we get 1.2 metre First Defence, link to the product page, standard drawings in PDF and CAD. 300mm in pipe sizes, again, different sediment storage capacities, and it is slightly deeper. There is no benching skirt to prevent re-entrainment in this unit, so instead it does have a bypass to protect itself, to stop anything that it's removed being re-entrained. It is a slightly deeper chamber than the same diameter Downstream Defender, as another protection against re-entrainment. And again, you've got the same basic information as you've got for the Downstream Defender. You've got the unit sizes, you've got the in and outlet pipe sizes that it needs to have in order to interface with internals, the mass treatment flow, which is slightly lower than the 1.2 metre Downstream Defender, the hydraulic capacity, and then the typical operating head loss and the maximum head loss, along with the storage capacities and sediment capacities. And again, you've got export and save functions. So we'll save this to the same test Clevedon site, and we will then, so you can all see the outputs, hit exports, and then if we go into projects, we should hopefully be able to see, let's reloaded, Downstream Defender, the First Defence, and the 2 Hydro Optimums. Now at this point, the ways to get in contact with us are, you can click the I'd like you to review my design button. This will then send an email to us and we can get in contact with you. The other options we have are in the support tab, in the bar on the top, in the menu on the top. If you click the support tab, you will get taken through to our support page, and if you have any questions, as well as our normal ways of getting through to us, there is a specific design tools at hydro-90.com email. So if you've got any reason why you might not be able to log in after the first time, or it's throwing up random errors, please email any questions to design tools email address. You can submit for review here as well as on the projects page, so I can check the test site Clevedon and hit the button here. And if you need to speak to an expert immediately, this will take you through to our technical hotline in our Clevedon head office. So that's the support tab. So please feel free to, if you've got any questions about the design tool or the units that are being sized in the design tool, please feel free to contact us through one of those avenues or our main number, main emails if you've already dealt with this before. Also, show you the design, drawing, and technical details for the first defender, very similar to the Dash Defender, giving you all the information that you need in terms of lifting. Very important to give that to contractors so they're aware of what they need to lift and how many lifts it is. They might not know that it breaks into pieces and it can be lifted in several smaller, lighter parts. And then you've also got the technical detail for the unit as well. So again, sediment type TFR course. I've seen a few questions in the questions box about the verification and questions about the grit size and also a head loss question about Dash Defender. These will be noted down, and either one of the internal team or one of the relevant regional technical managers will be in touch. We do have answers to all of these questions. I just can't fit them all in right now. So you've essentially got the same output for the first defense as you've got for the Dash Defender. And with that, once you've got that, you can send a project for review. You can then go in, start another project. You can add to projects that you've already got, etc., etc. And that is as far as I think the design tool is. Check. So for those of you asking, it is the easy URL to remember is hydro-int.design. That will take you to this page. It's the same page. It's just that it's a nice, shorter, friendlier URL to send to. So it will take you to the designtools.hydro-int.com/design page. It's just a bit quicker. And with that, thanks to everyone for attending. That's the end of the webinar.